Good morning, everyone. Today, I would like to presentation about for my topic. I want to say about actuator. My name is Mr. San Sunakumar. This was some list of the outlines for the whole presentation. It's multiple of the T parts. The first part is the definitions of actuator. The second part is the linear actuator, and the last one is the rotary actuator. The first thing I would like to say about the definitions of the actuator. The actuator is a device used to produce the actions or the motions. It's also operated by the source of the energy. It must encode the electric signal, air, food, and must be convert that energy into motion. Actuator is the mechanisms by which a control system acts upon to arrangement. And another thing is the actuator's output is usually mechanical in the linear displacement or velocity. This one I would like to display about the actuator functional diagram. This might have uh, two main types to might encode of the actuator. The first thing is the amplifier. The next thing is the transducer. For the amplifiers, it might convert the low power control signal into the highest power signal. But for about the transducer, it converts the energy of the amplifiers. It converts the signal into work. This one is the two types of the function diagram is mainly used in actuator. For specifically about the types of the actuator, this might be have the two main. The first thing is the linear actuator. The next one is the rotary actuator. For the linear actuator, this one is for this kind of linear actuator. The specific linear actuator is the cylinder, or we can call the linear actuator is the cylinder or length. It must be provides the motion is the straight line, and also given the linear displacement depends on the stroke length. It's it's not so in the finger. In this finger is so about the simple cylinder. This cylinder in finger is must be consists of the piston, radius R, and moving in the bore. The piston is the collect to a loss of the radius R with the dies of the load. Actually, if the pressure is applied to point Y, this point X is venting, the piston is acting. Similarly, if the pressure is applied to point Y, also with port X is venting, the piston is the lead track. This actually of the functions or the principle of the cylinder. For about the formula is the calculate the force. The force applied by the piston depends on the loss of area and apply of the pressure. For the extent stroke area A is given by the BR over 2. For pressure P is applied in the port X and Y. This is given on the formula of the just calculate the force. And also the linear actuator is must be simplest of the two type cylinder. The first thing is the single acting, and the second one is the double acting. Okay, for this slide, I want to display about the one The one single acting cylinder is the type of the linear actuator or cylinder. The single acting cylinder is a control pressure is applied to one side of the piston and also can simple to drive, but specifically for the pneumatic cylinder with the kick exhaust valve. But the float must be reduced to extent. And by the way, the spring return cylinder, the length of the cylinder is leakage for the given stroke to accommodate the spring. This is the definitions of the single acting cylinder. Looking at the picture display, uh, it must be so about the single acting of the cylinder. It have been imposed inside the fluid is inside the cylinder. Sigma effect from the extent of the cylinder. If we want to retract the cylinder, must depends on the spring movement of the directions of the cylinder. By the way, if the cylinder is used to lift up the load must be still can retract of the piston. This one is the principle of the single acting cylinder. Another slide I want to display about the double acting cylinder. This double acting cylinder is used to control pressure. It's applied to both sides of the piston. The difference in the pressure between the two sides results in motion of the pistons, but it's no spin. Probably, its double acting is must have two sides of the cylinder. Let's look at the picture. It is pair of the standard and typical of application. It's probably if we must impose the fluid inside of the cylinder or also the box outside, it must be equal the fluid is and also the float directly of the one by one it must be equal the float if we must impose the float uh, the box of the cylinder. Another way, the double load cylinder are commonly used in applications similar to finger B, where a dog is moved by the double load cylinder is acting via a change. For the formula to calculate the speed of the volume of cylinder, it must be determined by the volume of the fluid is delivered to it. But suppose but also suppose cylinder lay suppose the specific of the area inside the cylinder is also Smith's area and must be has the main move of distance or d is must the case that's formula of calculate of speed volume. For this part, I want to display about the construction of the linear actuator, also talking about some the main parts and the components of the cylinder, also linear actuator. Pneumatic and hydraulic linear actuators are construction in the similar manner, but also have some major different arising out of the difference in operation pressure. For example, typically cylinder, if we give the value of the hydraulic is 100 bar, and we give the value if of pressure in the pneumatic is 10 bar. But the difference is the we must consider the deviation from this value, and also display the components parts of the consider is based on the five main parts. The first part is the base cap or end cap, and another part is the bearing cap. The next thing is the value is also important. Um, and the next one is the piston inside of cylinder, and the last one is the load. Is the main components of the cylinder. In this duplicate picture, by the basic construction and although fairly the simple manufacture at the end cap and the piston are common to cylinder of the same diameter, but only relatively shift value and loss is needed to set to give different length cylinder. Next one, also continue about the construction of the linear actuator. I want to display about the inner surface of the barrels. It must be needs to be stably smooth to prevent the wear or leakage. Is the main functions of the barrel. It must be smooth surface to protect the leakage. And also the piston are usually made of the cast of the iron or steel material. This one display about some material to build the piston with the main components of the construction. Another part is for the wiper or scalper. It fitted to the end cap is where the loads enter the cylinder to remove dust particle. Looking at the figure A is so about the bearing cap of the cylinder. It might be have the some components of the bearing cap. It might be important is the wiper or the scalper or the scalper links. This one is to property to protect the some dust particle along with the outpass of the cylinder. Uh, the internal sealing link is fitted behind the bearings to prevent high pressure fluid leakage out along the load. For the sealing, you looking at for A, B, and C. For the picture, is also have the shell the shell to protect the leakage or the fluid leakage from the outside of the cylinder. Look at on the picture B. It must show about the some main construction. It might be includes the capsule, the loads, and the piston and valve. It might the combinations of the kinds of the construction of the cylinder. In another picture, see, it must show about uh, the importance of the shield or shielding is or much kind of difference of sealing in combination inside of the piston. Some kind is the O-ring seal, and another is the link link seal. It might be have O and U discipline for uh, uh, the the profiles of the structure of the cylinder. This one also some the constructor feature one by one of the construction for the linear actuator. The next thing is like I want to say about the mounting arrangement. For the cylinder mounting is determined by the application. It depends on uh, the works you want to use of the cylinder, but it must be have the two basic ties. It must show on the finger A and B. The finger A is all about the cam using front mounting, but feature B is so some another kinds of the cylinder is used for pusher using real Tenians mounting is also some another kinds of the mounting. This slides over to display some dynamic of the cylinder. The cylinder is used a lift a lot of the mass. It must be m, and assuming is lift track, and the top piston of the cylinder is visualized. The extending force is given by the expression. For the response of the simple system, it must show on the figure A. It show about the sums profile of the cylinder. We must can say this one is the double acting cylinder. It has the two pressure to input inside of the cylinder. Actually, as time m, the load size of the cylinder is must be have the ventage and the pressure inside must be apply applies the boss of size the piston. The piston on board of size the piston uh, must be changed exponentially with filling of the piston P2 slower than P1 piston because of the larger value inside the cylinder. As the time x, it must be extension of the P1A. It must be slightly than the P2A. But the movements of the movement it doesn't start until as the time y is given have the force. The formula to calculate the force is must so equal F equals P1A minus P2A. This formula to calculate the force inside the cylinder. It depends on the M to lift of the cylinder inside. For the next things is also important or the parts of the cylinder. I want to say seals. Seals just prevents leakage or also allow the control leakage. The leakage from the hydraulics or pneumatic system can be major problem. Leaking of fraud, leading a loss of efficiency, increased power usage, temperature, light, and also envelopment damage and the safety hazards. This is so importance of the seal on cylinder. Mostly people use the seals on the two types of the link. The first thing is the O-links, second is the U-link. For the O-links is primarily used at the static seals because any movement will cause the seal to rotate. Looking at on the picture is so about the some profile on the O-link and the static seal on inside on the piston cylinder. Um, the O-links can be specific in terms of the inside diameter ID is for fitting the shaft. And by the way, the outside diameter only is for fitting the ball. It's important of the O-links. It must be protects the high pressure on the piston cylinder. The second one is for the U-link. For the U-link seals, it's work on the same principle at the cap seal. The first pressure force to lift a part of each positive seal is so on the picture about the U-links. has uh, the two parts of the given positive ratio. For this slide, I want to display about the rotary actuator. The rotary actuators are hydraulics or pneumatics equivalents of electric motor for the given torque or power. And actuator does direct force in the circular motion. The rotary sometimes we can call motor. For the variable speed application, the complexity and maintenance requirement to rotary actuator are similar to the thyristor control DC motor. But by the way, the fixed speed application, the AC motor is the simpler to install and maintain. Looking at on the feature, is all about the rotary actuator. Um, the rotary actuator can be defined in terms of the torque, its products, and its running speed, usually given in less per minute or RPM. This must be rotated from clockwise or anti-clockwise. With a rotary motion, this product gives the plot of F and action as a dimension D from a sub of center. The device is the product is give the thought by the express on the formula. The thought equals FD. And this one also display the similarities of the actuator power source is supposed on actuator. The first is the stepper motor from electric motor and has the ability to move in this case step of the fifth sign. Second is the servo motor. Servo motor is the package combinations of the several components includes motor, gear train, position, and coaster. And the last thing is the first power actuator is stopped as the actuator internally constructions both of hydraulic and pneumatic power. That's it for my presentation about the actuator. Thank you for watching.